Hello students, today we continue with the topic distance and displacement, wherein we had in the previous lecture defined the distance and the displacement and stated the units used for measuring distance and displacement. Today we will try to understand it much better by differentiating between the two, that is the distance and the displacement. The first point was about the definition, that distance was defined as the length of path covered by a body or an object in a certain time. Whereas displacement was defined as the shortest distance between the final and the initial position. This I have explained you with respect to the diagram in the previous video. Second point was also covered, that it is a scalar quantity, whereas displacement is a vector quantity. Remember, it is a vector quantity because I had mentioned it requires direction. The third point of difference was it depends on the path, what road, what path it has followed. But here it does not depend. It does not depend on the path followed. For example, it depends on the path followed. Your object is moving from A to B. It has covered 4 kilometers. Then from B it has moved in a perpendicular direction and moved a distance of 3 kilometers. So it depends on the path followed. If it depends on the path followed, so here it is 4 kilometers plus here it is 3 kilometers. So totally it has covered 7 kilometers, which is the distance. That is why I said it depends on the path followed. But in case of displacement, I said it does not depend on the path followed. Why? Because in case of displacement, we see the shortest distance between the final and the initial position. So when I join this direct line from A to C by using Pythagoras theorem, I get this as 5 kilometers. So it does not depend. Here the displacement has become 5 kilometers. It does not depend on the path followed. Although the path followed was from A to B and then from B to C, totally making 7 kilometers, but this is not your displacement. Your displacement is 5, because in case of displacement, we see the shortest distance. So your AC is the shortest distance from initial to final or from final to the initial, that is 5 kilometers. Okay, this was the example or the understanding for distance and displacement. Further we proceed. The fourth point, that it is always positive. Distance is always positive, whereas displacement, it can be positive or negative. Please try to understand, positive or negative depending on direction. depending on direction in which the object is moving. Again, try to understand this. If the object is moving from A to B, distance is actually the length, and length is never negative. Length is either 1, 2, 3, 4. On this scale you might have seen 1, 2, 3, 4, all the positive digits, all the positive numbers. So distance is always positive, and positive in the case of displacement. When I say if the road or the object is moving from A to B in one direction, I need the direction, I specify again because it is displacement. So if it is moving from A to B, it might have covered some distance. Again from B to C, it is coming in opposite direction. So when it is opposite direction, displacement is negative. But if it is moving from A to B and again from B to C in the same direction, then your displacement becomes positive. Getting it? Positive or negative? I said positive or negative depending on the direction. If the two are moving in the same direction, it is positive. If they are moving in an opposite direction, it is negative. Okay, that was for the fourth point. The fifth point says distance is either more than or equal to the magnitude of displacement. More than or equal to, but here the magnitude is less than or it may be equal to the distance. Now, how do we explain this? Distance is more than or equal to the magnitude of displacement. As I said in the previous case, here, as I said in this case, the object was moving from A to B and then from B to C. So it covered the distance from A to B as 4 kilometers, then from B to C 3 kilometers. Totally it came out to be 7 kilometers. But in this case the displacement was 5. So can you see the distance is 7 and displacement is 5. So can I say that the distance here measured is more than the displacement? The distance covered is more than the displacement. So that was my point. More than. The distance is either more than or equal. Equal. How can I say it is equal? Let's take an example again. Object moving from A moving towards B, 5 kilometers. So distance, the length of path covered is 5 kilometers. So the distance is 5 kilometers. Okay, distance is 5 kilometers. Here again, the displacement in this same case, if I try to find the displacement means the shortest distance from initial to final position or from final to initial position. So this is your initial position and this is your final position. So again, the measurement remains the same. That is, again, the displacement becomes 5. So I have proved with 2 examples that it can be more than or it can be equal. That is what was my point. That is, the distance is more than or equal to the magnitude of displacement. So if the distance is more than or equal, your displacement will be less than or equal to. The reason remains the same. That is the 2 examples that I discussed just now. The next point in this is the 6th point, which says the distance may not be 0 even if displacement is 0. But there is an opposite part. But the displacement can be 0 even if distance is not 0, or vice versa of it. The opposite of it will be in the displacement. If the displacement, if it is 0, if it is 0, the distance may not be 0. Here the sixth point, it has a very deep meaning inside it, and this point can come as a separate give reason which is there in your textbook, but let me explain you this with respect to an example. For example, let us say, for example, your object from the ground level A, it is lifted to a height of h meters and it reaches the point B. Are you understanding it? Object lifted from the point A reaches the point B, that is at a height of h, and after that it again drops down, falls down under gravity from B to A, that is again it has traveled the same distance h. So according to the definition of distance, the length of the path covered, so length of the path covered while going up was h, and again while coming down the length of path covered again h. H plus h is 2h, which is your distance. So here the distance covered is 2h, but displacement in this case, let us discuss. The initial position is A and the final position is B. Object moving from A to B covers a distance of h, and again from B to A comes to covers a distance of h, but the difference, again the object started from A and the final position is again A. So according to the definition of displacement, the shortest distance between the initial and the final position, here the object is at the same position, so I can say there the displacement is 0. That was my sixth point. That is, it may be 0, displacement may be 0 even if distance is not 0. 2 into h, h may be any height, 3 meters, so 2 3s are 6 meters, 4, 2 4s are 8 meters. So accordingly displacement can be 0, but the distance cannot be 0. Same way, try to example the clock, a circular clock with hand, suppose at 12 o'clock position. So this hand of the clock, it may be a minute hand, hour hand or a second hand. It will cover the total outer boundary of the circle, that is called as the, can anyone? Yes, it is the circumference. The outer boundary is called as the circumference. So the object, here the hand is the object, it is covering the distance, that is the complete circumference of the circle. So here in this case, the distance covered is your circumference. If the radius is given to you, you can easily find the circumference of the circle. The circumference is 2 pi r, 2 pi r, where r is the radius of the circle. So here the distance covered is the complete circular round, that is the circumference, which is 2 pi r. So your distance is 2 pi r. Again I have proved here that it is not 0, but the displacement stands as the hand, clock hand was at 12 o'clock position. So this is my initial position. After covering the complete circular round, it has again finally reached here. So it is your final position. So here both the initial and the final position remains the same, and therefore the displacement is 0. So in both the cases I have tried to explain you that displacement can be 0, but the distance is not 0. May or may not. Getting it? So we just revise what we have differentiated it as: the distance and the displacement. I said the definition, it is the length of the path covered by a body in a certain time interval. But in case of displacement, it is the shortest distance, chota, yes, it is the shortest distance between the final and the initial position of the object. Here it is a scalar quantity, displacement is a vector quantity because it requires direction. Distance depends on the path followed, what path it is following, whether a straight line or a zigzag path or a perpendicular direction. It depends on the path followed. But here it does not depend on the path followed because we don't see at the path, we just see at the shortest distance. Getting it? Here it is always positive because distance is just the measurement of a length, and the length is never negative. It is always positive. But in case of displacement, I explained you two cases. It may be positive or it may be negative depending on the direction. To go into detail, I said if the two objects are traveling in the same direction, I can add up. That is, it remains positive. But if it is one moving in the one direction and the other in the opposite direction, if it is traveling in opposite direction, we consider it to be negative. So it may be positive or negative depending on the direction. Here the distance can be more than or equal to the magnitude of displacement. Magnitude can be more than or equal, I explained you more than in case of that object moving from A to B, B to C, Pythagoras theorem coming out to be 4 plus 3, 5, distance is 5 and the displacement was 5 kilometers. So it was always, distance is always more than or it may be equal to the magnitude. So the opposite of it stands as it may be less than or equal to the distance. And the two cases which I showed you as a give reason part, the important part of the chapter, that is the distance may not be 0 even if the displacement is 0. I gave you two cases: the object dropped vertically upward and downwards and a clock or a circular object. It may not be 0 even if the displacement is 0, but the displacement can be 0 even if the distance is not 0. The opposite of it stays the same. If it is 0, if the displacement is 0, not necessary that the distance is 0. Distance may not be 0. Getting it? So this is all about distance and displacement.